mic on. Okay. So, Ochamaga, what's this? Construction of geometric figures, lines, and angles. Is this the beginning of the chapter? Okay. Read for us the opening paragraph.
A line is made up of infinitely many points.
Okay.
A straight line is always the shortest distance between 2 points.
Okay, pause. Ne? The first part, yeah, a line is made up of infinitely many points. What do you understand by that? What do you understand by infinitely many points? Okay, so do this now. Geometry. So this part, infinite. Do you know what the word infinite means? What does it mean, Tavis?
It's like forever, like it's like
going on forever without end. Yeah. Yeah. So infinitely means without end. Ne? So any line you can think of has infinitely many points, even if it's this distance here, or that distance there, or that distance there. The points inside each of these lines are infinitely many. Ne? You could have a point there and a point there, and in between them you still have infinitely many points. That's what that means. Ne? So yakohala now, infinitely many points. Okay. And then again, a line is the shortest distance between 2 points. Okay, that one is straightforward. Yeah, it's okay. Then read the next line.
A line can extend in both directions forever, but a line segment has a definite beginning and definite end.
Okay, what do you understand by the word definite? Definite, what do you understand by the word definite? Tabiso, do you understand what the word definite means? Okay, so initially we started with infinitely many, right? Infinite meaning without end. Definite means a set amount. It's defined. The amount is defined. Ne? So definite, defined. Ne? Defined meaning you've been given where it starts and where it ends. Ne? So from start to finish, we know where the line starts and where it ends. That's a line segment. Ne? Alright, so this applies to line segment. Alright, so you will have a line that stretches in any direction infinitely. Ne? But a line segment will start from there and end there. So that would be a line segment. That would be line segment. Ne? Right, then the next part, to construct a line.
To construct a line, always use a ruler.
Always use a ruler. Why? Do you think that's important? Why do you think that's important?
So that the line can be straight.
100%. So it can be a straight line. Okay. And then what else?
Place the point of a sharp pencil on the ruler at 0 centimeters. Then draw a line to the distance required as shown on the ruler.
Okay, so this is a basic exercise, right? You have your line 0, 2, 3, 4, 5, 1, 2, 3, 4, 5. Right? Five, 1, 2, 3, 4, 5. So let's say you have a ruler and it looks something like that. Maybe a lot straighter, but yeah. So what they explain is to draw a line, you take the tip of your pen and you trace that line along the edge to a specified distance, right? And that would be your line and pen. That's what is explained there. Okay. Then the next part. What is the next part about?
An angle is made when two lines meet at a point.
Okay, so we have a line. So angles, not angels, angles. Angles, ne? So a line would go this way and another line would go that way, isn't it? Now, what does it say about an angle? It's made when?
Two lines meet at a point.
Alright, so here's the point where they meet. You get it? Alright, so what forms between those two lines is an angle. So you get an angle there, you get another angle there, you have another angle there, and you have another angle right over there. So you get more than one angle. Yeah. Okay, then carry on.
The point at which the two lines meet, it is called the vertex.
So this equals vertex, ne? Vertex, I think it's a Latin or maybe Greek, I don't know, but it's a word. Let's look it up. Vertex meaning. Right. The highest point or the top of or apex, ne? So in other words, it comes from when you're looking at a mountain would look like that, right? And right at the top there, that's called the peak or the vertex. Maybe let's make it a green flag. I want to spread green flags all around. Yeah. So this is called a vertex, ne? And the same thing that we learn from nature, we apply to maths. And we call that point a vertex. Because if you think about it and you look at it from this side, let's say that's your eye, this kind of looks like the mountain there. This looks like the mountain peak, and there is your vertex. All right. Then the next point.
Angles are measured in degrees.
Okay. Measured in degrees. And carry on.
1 degree is 1/360 of a full revolution. The table summarizes the different types of angles.
Okay. So before we get to the different types of angles, a revolution, do you know what that means? Revolution. What does a revolution mean? You don't know? Okay. Do you know what a revolver is?
Yeah.
What's a revolver?
That's a gun.
It's a gun.
Yeah.
Why do you think it's called a revolver?
Um,
Because the magazine where you install the bullets rotates around a central point. So each time a bullet's fired, that's why it's called a revolver.
that one. Oh yeah.
You said it's a gun, and I'm explaining the gun how it works.
Oh yeah.
Yes, and the guy who invented it, I think it's Glenn Curtis, I'm not sure. He used to work on a ship. So back in the day, ships would have Pirates of the Caribbean, you've seen that, right? Those steering wheels of the ship. So he got the design for a revolver from having worked with those steering mechanisms of ships for a long time. Yeah. So it's called a revolver because around the point where the bullets are fired, the magazine rotates. So revolve means to rotate around a point. Like your door revolves around the hinge, this laptop lid revolves around this hinge, etc. your flip phone, it revolves around the hinge. So that hinge is a point of revolution. So from the word revolve, we get revolution. And revolution means to go in a circle. Right. Now from this, which are things we interact with naturally, we get a revolution. So now a revolution, if you have a point and a line runs from it, if you take that line and it rotates around the point, making a revolution, that is regarded as 360 degrees, right? And each time, like on your protractor, it said there, and angles are measured in degrees, yes? And 1 degree is like a very thin pizza slice. Very thin pizza slice. So unlike linear measure on a ruler, on your protractor, you will have these degrees. So you'll have that 1 degree there, that 2 degrees there, that 3 degrees, etc. Right? And each one of those equals to the next, and the space between them that makes an angle is 1 out of 360. That's 1 degree. Right. So you get 360 of those, then you get a revolution. So 360 degrees equals a revolution. Because each of those angles rotated about the point where the angles are measured. All right. Now let's get to types of angles. Types of angles, yeah. What is the first type of angle?
Acute angle.
Acute angle. Do you know what the word acute means? You don't know what the word acute means, Mr. Rapper. You no longer want to rap. Yeah? You need good English if you want to rap, eh? Acute means it means a lot of things. But one of the things it means is severe, critical, drastic, dire, astute, sharp. Sharp is one thing. So when you look at Ntlhana ya pen ya gago, it's sharp, isn't it? So it looks like that acute angle. It's sharp, right? So anything that's sharp, we say it's acute. Even illnesses are also described as acute. Some illnesses are described as acute because it introduces a sharp trauma to your body, or that specific part of your body that's infected or affected by the illness. So acute angle, we can think of them as sharp angles, and they look like this, ne? All right. And then the next type of angle?
Right angle.
Right angle. It's called right probably because this corner looks right. It's square. Right? So every time you see a 90-degree angle, be it the corner of your screen on a computer or device, or corner of this battery charger, the windows, the wall, whether it's between these two walls or between the floor and the wall, that angle is 90 degrees, ne? And it's called right angle, right? And then the next type of angle?
Obtuse angle.
Obtuse. Obtuse, do you know what the word obtuse means? You don't know. Would you like to take a guess? Okay. So, in language use, obtuse means unknowingly insensitive or slow to understand. It can also mean stupid, dull, slow-witted, slow, unintelligent, etc. But that's just the English use. But in maths, because it's not a sharp angle, it's a blunt angle. So blunt meaning it's not sharp, obtuse. I like the word blunt. And not for social reasons, but it's more than 90 degrees, but less than 180 degrees. It's not a sharp angle, it's a very blunt angle. So if you were to think of it as an edge of a knife, it wouldn't be a very sharp knife. But if this was to be thought of as an end of a knife, it would be a sharp knife. Difference, that one. Fourth type of angle, straight line, yeah? Straight line is half a circle, if you think about it. So straight line, 180 degrees. So that's literally that revolution, but divided by half. Or rather, divided by 2 or times a half. Yeah. Then what other angles do we have?
Reflex angle.
Reflex angle. Why do you think it's called reflex? Why do you think it's called reflex? When you were sick recently, did you go to a doctor? You didn't go to a doctor. When last did you visit a doctor?
Primary.
In primary. When you're sitting on their bench there and then they hit you more on your knee with a little hammer, what happens to your knee? What happens to your leg? You're sitting and they just hit you on under the knee there with a little small light hammer. What does your leg do? Okay. Let's say you're sitting on your desk and you try to turn to your friend and you hit the corner of their desk there. What happens when you feel that sharp discomfort here? What happens to your arm? Yeah. You bump into a thing with your joint and then you suddenly straighten it out. That's a reflex.
Yeah.
That's a reflex. You grab onto a hot stove, your hand runs away. That's a reflex. So you think about reflex angle in the same sense as your joint. When you hit against the corner and then you straighten it out. Because you're trying to reflex, you are reacting to a stimulus. So maybe the disconnection is not very clear there. Again, the connection is not very clear there. Mar. The point is, when you think about how your joints reflex when they are feeling certain things and you don't even think about that reaction, that's a reflex. So you can think about it in the same for this angle. And then the last angle, key revolution again. Okay. So does this cover everything that starts the geometry chapter? Okay, so now we're ramping it up. Measuring angles. So when measuring angles, what does it say there?
Place the vertex of the angle at the center of the protractor. On a semicircular protractor, place the vertex at the center of the base line of the protractor.
Okay, so I'm gonna draw a simulation to show. Okay, let's say you've drawn an angle with a blue pen. Ne? You've drawn an angle with a blue pen. Ne? You've drawn two lines, they intersect, and there's a vertex there. Now, if you want to measure the angle here with a protractor, what do? Your protractor tends to have, it's a semicircle. Often it's a semicircle. And then it has like a cross, which shows from 0 to 90 to 180 degrees. And it can also be 180 degrees, 90, and then 0 degrees. So each degree will increase either in this direction or in that direction. So it can be 1, 2, or 179, etc. You've seen that most on your protractor. All right. So we're gonna place this vertex onto here. So if we have a protractor, our protractor would sit something like this on the shape. And yeah, so then when we measure it, we would have a reading there, isn't it? Yeah, so that's how we measure with a protractor. Okay, and then the next part.
Match the 0-degree line on the protractor with one of the lines of the angle you are measuring.
Oh, okay, so that's explained in the sketch, this whole process. Yeah, so we can skip to the next. Okay, then how to construct angles using a protractor. Read that part out for us.
Draw a straight line and place the center of the baseline of the protractor over one end of the line.
Okay, so let's say we have a line. Okay, then carry on reading. We've got a line.
Ensure that the line is exactly lined up with the 0-degree mark on the protractor.
Okay, and then what else did you say? Sorry.
Find the required angle size on the scale of the protractor and mark a dot next to it.
Okay, so in other words, let's say we have a protractor and they want us to draw 11 degrees, right? So if we're drawing 11 degrees, let's say our protractor runs somewhere there. Then 11 degrees would have 1 degree maybe somewhere there. Okay, maybe that's 2 degrees. So let's make that 2. 4, 6. Just left click here. Right. This is probably more than 11 degrees, but this is not accurate, né? So let's say we have a protractor there. You've drawn our line, and where we've got the intersection, we put the corner of the line, isn't it? Now after that, we measure all the way up to 11 degrees, right? And then we make a mark there. So then we remove the protractor and we finish off. So when we remove it, we'll just join that point there and that point with a ruler, and we can have that angle of 11 degrees. That's how you use a protractor. Okay. So that's the explanation here, this procedure. Right. And then the next part, constructing a 90-degree angle using a pair of compasses and a ruler. Okay. Read that one out for us.
Another way of constructing angles by using compasses, a pencil and a ruler. Draw a baseline of any convenient length using a ruler.
Okay.
Name this line segment AB.
Okay, so we've got AB, that's our line segment. And then the next part?
Place the point of the compass on one end of the line at A and open the compass to just over half the length of line AB.
Okay, so let's say this is 10 centimeters. Then we'll put the compass so that it's between A, which is 0, and a point, we'll call that point X, which is halfway, right? And then the next step?
Place the compass on the other end of the line at B and keeping the compass at the same width as in step 2. Draw
Okay.
a line ARC above. Draw a small arc above and below the line.
Okay, so in other words, you have your compass there, then you'll draw an arc there, and you'll draw another arc there, right? And you do the same from B. and you draw an arc, and you draw another arc. So what that does is, you have your compass like that, ne? You draw an arc. It draws in a circular manner, and it also draws in a circular manner there. Then you do the same on the other side. It draws a circular manner and another circular manner. So what happens is you get a point that intersects, and you can just join those two lines. And when you do, you will have a 90-degree angle. So that's what's been explained there. Then the next part of the chapter,
Construction of geometric figures, triangles.
okay. I think now it's getting more geometry. Yeah. So read for us the first paragraph.
Constructing a circle. Open the arms of the compass so that the distance between the arms of the compass is equal to the radius of the circle.
Wait. Open the arms of the compass so that the distance between the arms of the compass equals the radius of the circle. Okay, so let's say you've got a length. If we make our compass to be that long, then if we make our compass to be this long, if we rotate, we will draw a circle that goes around, and that would be the radius. So in other words, our circle would go around this way. Yeah. Because the compass, its center is there. The one arm is fixed here in the center at the end of the line. And at the end of the radius or the line segment, the compass would rotate all the way around like that. That's how the compass would work. You've used compass before, no? Right. Okay, so we're just revising. Okay. And then, so that completes the circle. Yeah. Okay, just finish reading off the paragraph.
The point of the compass becomes the center of the circle. Draw a curve around this point to complete the circle.
Okay. Then the next part,
Constructing a triangle.
constructing a triangle. So we've done circle, then we've got triangle. So we've got triangle. Okay, read for us.
If all three lengths of the sides of the triangle are given, the triangle can be drawn accurately using a compass, pencil, and rule.
Okay, so what the book is suggesting is that if you have a triangle, maybe let's say this side it's 5 centimeters, the one side it's 3 centimeters, and on the one side it's 4 centimeters, then you can easily draw it to that scale, to that size. Then the next part, triangles can
Also be accurately constructed if two angles and the length of the side between the angles of the triangle are given.
So if two angles are given, so we're given two angles, what else?
The lengths of the two sides of the triangle and the angle between these two sides are given.
Oh, okay. What that means is if we have two sides given and an angle, then we can draw a triangle accurately. So let's say we've got a side that's 4 centimeters and another side that's also 4 centimeters, and maybe we're given this angle as 70 degrees, ne? So if we take our protractor, we draw a line at 70 degrees, that's also equal 4 centimeters. Then we can just join these two lines to close the shape and have a triangle. And we'll find that this is a triangle where two sides are equal and they place between them an angle. Yeah, so that's what's explained there. And the next part. Investigating the angles of a triangle by construction. You have compass again, and you have protractor, and you have pencil. Okay, do this as an exercise for yourself. But first, I advise read these things and follow the instructions step by step. Yeah. So that will be your exercise for your homework. Yeah. Okay, so we are going, just read for us this part here, because I want us to get to this thing here of a triangle. I think it's a very important rule.
Construct a triangle with two sides equal to each other and the third a different length. Measure the angles of your triangle. What do you notice? You should notice that in your triangle, the angles opposite the equal sides are also equal.
Okay, hold it right there. What they're explaining there in the book is this triangle here, where two sides are equal length and the one angle is its only size, but these two angles are also equal because they are adjacent to the sides that are equal. So this is called an isosceles triangle. Isosceles triangle, Have you heard that name before? Isosceles triangle? Never. Never. Okay, let's look at it. Isosceles triangle. Isosceles. An isosceles triangle is a triangle that has two sides of equal length, and sometimes it is specified as having exactly two sides of equal length, and sometimes as having at least two sides of equal length. So, but the long and short of it, Goring, whenever you come across a triangle, and you'll come across many of them, where the one pair of sides are equal, in between those two sides that are equal is an angle that could be given, or you could be given the bottom two angles, and those two angles would be equal. So, do you know what the sum of angles in a triangle equals? Not yet, okay. So, I want us to do a quick, short, little hands-on experiment, So, quick experiment. I'm gonna draw a triangle for each one of us on a piece of paper. It's gonna be different triangles, but what I want to illustrate, what I want to show is not exactly this, but the sum of angles in a triangle, because I see you gentlemen don't know that one. So let's make nice big triangle. Remember, angles on a straight line are 180 degrees. The straight line is 180 degrees, remember? So that means even if you have angles on that same straight line, they will add up to 180 degrees. So I want to do this little hands-on experiment so that you can see the relationship between angles on a straight line and angles inside a triangle. So these are random triangles. I did not measure them. but I drew them in such a way that you can see them and play with them. Ne? Let me make a scalene triangle. Make a scalene triangle. Okay, cut that triangle up. Do you know how to cut it? How are you gonna cut it?
Like on the...
Yeah, on the line. How are you going to cut it? Because I'm gonna use a ruler. You guys don't have a pair of scissors, eh? Okay. Do you guys know how to cut paper like this? Travis, yeah. Young man, I'm worried about you. You've never seen this trick before? Or you've never used it?
Yeah.
You never used it? Okay. Alright. Okay, so there's your triangle. Give me the other page. So I just want to first show how there's a relation between angles in a triangle and angles on a straight line. So that you see this visually, then you'll always know it when you're writing a test or an exam. Ne? So just label on it so that you can always recall this when you're writing a test or an exam. Still have to make the third one. That's fine. Okay. Okay, this one will be my triangle. Because Gingati. And this one will be Kopano's triangle. Kopano's triangle. Right, so in geometry, you'll always come across this thing of either angles on a straight line or angles in a triangle equals 180 degrees. I just want to make you guys see that. So that label on it. And then it's not new when you have to learn it in class or use it in your test. Ne? And again, a lot of here's your triangle. Ne? So now you've got pens again. There's the one side and the back. I want you to make one angle have one you see like this angle measure thing. It must be one line, ne? The second one must have 2. The third one must have 3 because we've got 3 angles in a triangle, right? So this one will be 2. And this one will be 1, 2, 3. You see that?
Oh.
So the first angle you choose will have 1, yes, and then the third one will have 3. All right.
So it's like 1, 2,
Yes,
3.
exactly. Exactly like that. 2 and then 3, right? So it's a triangle. Triangle means 3 angles. Yeah, it means 3 angles. Ne? So I want you to hold one side as like it's gonna be on the floor. Yeah, like this. Ne? Now, make these face to me. Yeah, like so. These, yeah, those can face like that. So you can fold the angle at the top so that the tip touches the line at the bottom. Like this. So that the tip touches the line at the bottom. So you'll see how you folded it, ne? Where it's folded, it'll be straight and parallel to the floor. Yeah, like that, Papa. Yes. Let me see yours. Yeah, also like that. That's correct. That's correct. Now, you fold the other angles toward the point that you folded. But so that towards the point that you folded, so that that's why I said these must be this way, so that when you fold it, they come together like that. You see? So when you fold it, it comes and joins the other nklana there. You see? Let's see yours, Kopan. Yes, like that, you see. And then you do the same with the third angle, so that it comes to the front like this. Yeah. So what does that show you? It shows you that when you take the first angle, the second angle, and the third angle, you get a straight line. And straight line, we said, is 180 degrees. But also, when you unfold those three angles, they can also be part of a triangle. So every time you think of the angles in a triangle and angles on a straight line, they both equal 180 degrees. Now, why did I want to make us do that exercise, ne? It's because this part you've just read about triangle having two equal sides, an angle in the middle, and two angles at the bottom equal. It's called an isosceles triangle. So one of the quick things you can teach yourself is, if I have an isosceles triangle, if this angle is A, and that angle is A, and that angle is B, ne? Then, and this side equals that side, ne? So let's say A, B, C, right? So if AB equals AC, then the angle at B equals the angle at C. Right. So this you're gonna come across from now when you're starting it into grade 10, 11, and 12. You'll always see this. You'll always see this. And I like to explain like this because I don't want you to think, or once you do grade 9 maths, you're not gonna need it in grade 10. You are going to need it. It just gets more developed, gets more complicated. So if you don't understand it now in grade 9, you might not understand it in grade 10, 11, and 12. So I'm only sharing this because the sum of angles in a triangle are 180 degrees. So that angle plus 2 of this angle must equal 180 degrees. Now for an isosceles triangle, that's always the case. The angle at the bottom next to the one side and the angle at the bottom next to the other side that are equal, those are the angles that are equal. And in between the two sides that are equal, that angle is the only one that doesn't have the same size as those two. So you can always keep that in the back of your head. It's a very simple thing to remember, but it's useful. It's very useful. Now let's read into the next part.
Investigating the exterior angle of a triangle by construction.
Okay.
Construct an equilateral triangle, three equal sides.
Okay, stop right there. Do you know what an equilateral triangle is? What is it?
A triangle that has three equal angles and sides.
Three equal angles and sides. The name in and of itself explains itself. Equi means equal. Lateral is a side. So equal sides triangle. That's what equilateral means. Ne? So, okay, carry on.
An isosceles triangle, two equal sides, and a scaling triangle, no equal sides.
Okay.
On each triangle, extend the baseline AB to D as shown.
Alright, so what the book is explaining to us is we'll have a triangle like this where all the sides are equal. We'll have a triangle where only two sides are equal and two angles are equal. And we'll have a side, or rather a triangle, where all the sides and angles are not equal. Ne? So these are the three triangles. Okay, carry on.
Use a protractor to measure interior angles angle angle CAB and angle ACB.
All right, cool. So how this is described, the point at the end of the line ki D again, and then A is the one here, and then B is the one here at the base of the triangle. Then at the top there you've got C. Right, now in geometry, when we read out angles, this angle here, so let's just make them different colors. The angle at C will use blue, the angle at A will use green, and the angle at B will use yellow, right? So we're gonna do that for each of these. So I just want you to, because I can see already when Kopan is reading out that hore, it's like it's starting to be tricky. So I don't want that confusion. Let's deal with it now. So what are they saying there? We must measure angles CAB, right? So angle CAB, when they speak about the angle CAB, and notice there's a little hat on top of the letter A. That hat shows you where you have the vertex. That's the point of the hat. Another way you can write this angle is to say angle CAB. This doesn't mean the vertex is at C. It just means you are referring to the angle where we start at C, have a vertex at A. So we start at C, have a vertex at A, and then we end at B. So that's how we call out angles in geometry. This one I like the most because the angle where there is a vertex, the point where there is a vertex, is the one with the little hat. So it deals with confusion. But this way of writing is also still correct. So that's what in the book we're being explained. Yeah? So we start off with angle CAB, and then we measure again angle ACB, yeah? So ACB would be A through C all the way to B. So ACB, ACB, né? And that just means CAB is the green angle, so it's this angle, and oh, that's ACB. No, wait. CAB is the green angle, and ACB is the blue angle. Yeah, yeah. So in other words, if we're thinking about the blue colors only, ACB starts at A, turns at C, then ends at B. Starts at A, turns at C, ends at B. Starts at A, turns at C, ends at B. That's what that means. Né? Then ACB, Tomako A, turns at C and B. Or maybe I'm saying the same thing again, but you get the idea, yeah. So, okay, then the next instruction is to do what?
Calculate the sum of the angles. CAB and ACB.
All right, okay. So again, you two gentlemen must make this kind of exercise your homework. Draw accurately a triangle. Do you have a ruler and a protractor? Okay, so when you get home, you must draw these triangles for yourself and then draw them accurately. So the exercise prompts you to measure this angle DBC, right? This angle here, DBC. Why is that angle important? Because in all of these three cases, when you finish this exercise, you will see that if I add this angle and that angle, they give me this angle. If I add this angle and that angle, their sum gives me this angle. And this applies to all the three triangles. And what is this rule called? The exterior angle of a triangle equals the sum of the interior opposite angles. Do you know what the words interior and exterior mean? Okay, that's good. So far, we're still together. All right, cool. So I just want to quickly see. Kopano, where did you say you wanted to start geometry? Oh, parallel lines and straight lines. Okay. We're going to do that in our next class, Thursday. So I want us to just pause here so that we can attend to Tabiso's maths, which is factorization. All right. So factorization, what do you understand by factor? By a factor?
Factor.
Yeah. What is a factor?
You times other numbers.
Like, okay, I'm not sure what you want to express, but let's look at it like this. I think I'm sensing you want to say numbers that you can multiply and you'd still be able to get certain part. But let's look at it like this, ne? If we look at the number 10, ne? What numbers can 10 be divided by? 1. So for the number 10, 1 is a factor. That's correct. Is that the only one? The number that 10 can be divided by. Is it only one? 2. Okay. What is there another number, or are these the only two?
5.
5. Okay. Are these the only 3 numbers, or are there other numbers? Okay, we'll put 10 there, but I'll just circle these. Ne? Let's just focus on 2 and 5. How many times does 2 go into 10?
5 times.
It goes 5 times, right? And how many times does 5 go into 10?
Once.
No, twice. Yes. Right. Now that's one example of factors that you can think of when you think of factors. Always when you're thinking in terms of factors, what number do I need to multiply this number by to get that outcome? So in other words, if Kenya got 10, which numbers must I multiply with each other? 2 and 5, 1 and 10. You get it? So that's how I would think of factors. But let's start with expanding it so that we can go back to separating them. So let's start here. Algebraic expressions. Expand and simplify algebraic expressions. So read for us, ne?
When you have a bracket multiplied by something in front of the bracket,
Mm-hmm.
multiply every term inside the bracket by the term in front of the bracket. This gets rid of the bracket.
Okay. So in algebra, remember we've got BODMAS. We talked about BODMAS the other time, right? It's brackets, order, division, multiplication, addition, and subtraction. We spoke about that here. So when we have an algebraic expression, so in the example, we've got 5a, and it's multiplied by a bracket, and inside the bracket, we have b minus c, yeah? So what does this tell us? In the first place, we cannot subtract b, or rather we cannot subtract c from b, because we don't know the value of c. We don't know if it's 2 or 100, and we also don't know the value of b. We don't know if it's 8 or 12. We also don't know the value of a. We don't know if it's 1, we don't know if it's 20, we don't know if it's 16. So these three are unknowns, but they can be operated on using BODMAS, as in this case. We've got brackets. I get it. So now, when we expand this, so if you think about, and I'm going to show you how this relates to factors, so just bear with me. So if you think about it, we multiply the 5a by the b. Are you too familiar with how we multiply like this, distributing?
Yeah.
Okay. So that's the first step, and then the second step we multiply like that. Yeah, so we'll have 5ab minus 5ac, correct? Right. Now, when you think about, so this is a forward direction, eh? Think about it as going forward. We're going forward in that direction where we distribute and multiply. Now, to factorize would be going in reverse. You get it now?
Yeah.
So to factorize would be going in reverse. So if we have 5ab minus 5ac, we have to first identify a factor. Ne? Now, when I started this section of the class, I said that what are the factors for the number 10? And we started with the number 1. Yes, 10 is divisible by 1. And then we came with the number 2. Yes, 10 is divisible by 2. Then we came with the number 5. Yes, 10 is divisible by 5. And then we came with the number 10. Yes, 10 is divisible by 10. But let's put 1 and 10 aside because those are easy, right? I wanted you to think about 2 and 5 because you can multiply 2 and 5 to get 10 or 5 and 2 to get 10, either or. But that just means they are factors of 10. So if you are going to factorize the number 10, you would take out the number 2 and you'd be left with 5. And if you multiply those two, you get back to 10. So that's how you think about factors. The same way, here, we have to identify a factor. Now, what is the common factor here between the term 5ab and 5ac? What's the common factor there?
5.
That's partially correct. Partially correct. Because if we look at the number 10 and we take out the factor of 2, that's 100% correct. Because there's no other number we can multiply 2 by except 5 to get 10. But now, in order for me to get 5ab, ne? So think about this where we started. And think about how we're going to go from this to back where we started. What is the common factor for 5ab and 5ac? In other words, the number that you can multiply with something to get 5ab, and the number you can multiply with something to get 5ac. Which one is common between them? The answer is right before our eyes, and it's right here. So the common factor here, what's?
5a.
It's 5a. Why do you say it's 5a?
Because we use it to multiply b and c.
Okay, and what happens if we multiply 5a by b?
It becomes 5ab.
It becomes 5ab. And what happens when we multiply 5a by c?
It becomes 5ac.
All right. So, Tabiso, I wonder why I said your answer was partially correct. 5 is part of the factor, but it's not the complete factor. So the complete factor is 5a. Because when you take that out of our system here, by identifying 5a, then if we take it out, we will have 5a times b minus 5a times c. And now you realize just by splitting those two up, we get our factor here 5a and our factor here 5a there. You get it? Right. Now the last step in factorizing would then be to, once you've separated the 5a, we look now at the signs, the symbols that accompany these numbers. So we've got b, which is positive, and we've got c, which is going to be negative, because if we take out 5a, we didn't take out the negative 5a. So the sign there doesn't change. And all we're left with is b minus c. Is everything all right?
Yeah, I just feel like
Feel like what?
to throw up.
Are you feeling nauseous?
It's fine.
Are you sure? Okay, so let's do the next one. If we have a negative sign, what happens? So read out first there.
When you multiply out double brackets, you get 4 terms, and usually 2 of them combine to leave 3 terms.
Wait, where are you reading?
This one.
When you multiply out double brackets. Oh, okay. Okay, I see. So it's 3x squared minus x plus 1. Okay. Yeah, no, carry on. Carry on.
Multiply every term in the first bracket by every term in the second bracket. Then simply, where possible, use foul so that you remember to multiply
It's
4
foil.
times.
First,
Foil.
outer, inner, last. Ne? All right. So what they're saying is that when you have 2 brackets like this, ne? Got 2 brackets like this, ne? The technique that we apply is called FOIL. Ne? So let me just write this right at the middle so it's nice and big. Ne? In fact, let's use that example they gave. So it's 2a. Can you call it out for us?
2a plus 4 bracket 3a minus 7.
3a minus 7.
Yeah.
Okay, cool. So what's shared with us is called FOIL, ne? So let's do this. First, outer, inner, last. Can you read out what they say there about FOIL?
F multiply first terms together. O multiply outer terms together. I multiply inner terms together. L multiply last terms
Together. Okay, excellent. So now let's visualize. Ne? So you see in your book they've got arrows showing there. Ne? It's a way to visualize so that you can see it in your mind's eye, so to speak. And that's the nice thing about maths. You have to really use your imagination. Which if you're not gonna use your imagination, you're gonna struggle. So yeah. When they say first, we multiply the first terms together, ne? So the first terms would be, we read from left going to right when we read normally. So even here, we will apply the same method of looking at our work. So we multiply first the first terms, then we go for the outer ones. So 2a and 7 are the outermost terms. That's why they're called outer, right? So the blue one will go for the first. The green one will be for the outer terms. Then the yellow one is for the inner terms, so the ones inside. And the red one is last. So that's what gives us the FOIL. That one. So this way, you follow this procedure. You start with this 2a, you multiply it by the 3a. And how do we do it? So we'll have 2a times 3a, and that equals 6a squared. Do you understand how we get the 6a squared? Okay, can you explain that?
So like cause like the numbers are like two of them, so it's like to the
Okay, but you didn't really say anything. You haven't really said anything. You want to give it another try? You can give it another try.
I don't know.
You don't know. Okay, Kopan, would you like to try? Okay, try.
I think we will be multiplying 2 and 3. It will give us 6.
Okay.
And when we multiply the same basis, it gives us to the power 3.
Remember exponents, when we have same base, we add the exponents. So the base is a, and the exponents are 1, 1, so we add them since we multiply. So laws of exponents still kind of features here. You see? So everything we learn, we don't learn to say, I've done this chapter, let me forget it. No, you say, I'm learning it, and then you're still going to use it somewhere else. Right, so we've done our first ones. Now let's do our outer. So that's going to be 2a times negative 7, yeah? And what's the answer there? Tavis, would you like to give it a guess? 2a times negative 7. Would you like to give it a try? Let's hear.
-11.
No, that's far from correct. think about it. Remember, we are multiplying. So if we have numbers, we can multiply those numbers. But if we have an alphabet that is unknown, we can just attach it to the number, so to speak. Yeah. Attach it.
19.
Minus 19.
Yeah.
How did you get to minus 19?
And we like
We're multiplying.
going, yeah.
Yes, we are going in that direction. Agree. The first step in multiplying double brackets, we start with the first terms, then we do the outer terms. So we're doing the outer terms. So if we're multiplying the outer terms, it's 2a times negative 7. You understand that part, right? So how do we multiply then 2a with negative 7? And what's the answer there? Take your time, think about it. It's not clear. Okay, Kopano, would you like to give it a try? Let me ask you this question. Let's say we've got the number 2x and we're multiplying it by 3. What's the answer there?
Five.
It's not 5x. Good try, but it's not 5x.
6x.
6x. Okay, that's correct. How did you come to that conclusion?
How?
Yeah, how did you figure it out in your mind? Explain to us that process.
I guess it's like 2 times 3, so like
Okay.
when I times and I always start like the, like if it was like
So you start with the
times
number
2.
that doesn't have an x to it. And then you multiply it with the number that's next to the x, so to speak. So in other words, you multiply by saying this 3 times that 2.
Yeah.
That's how you thought about it. That's okay. I guess it works. And it got you the correct answer. I wouldn't exactly go about it like that, but I would think about it like this. I've got 2x that is multiplied 3 times. So it's 2x, the first one, another 2x, and another 2x. So when I add them, the x doesn't really change because I'm adding, and I just add these 6's. Because that's 2x 3 times. It's still the same. Now, it might get tricky when you have to multiply by a negative number, but the logic still works the same if you think about integers. But nevertheless, you're correct, and if you thought about that and you trust it, your method, by all means go for it, and that's OT. But now, can you use the same logic for this one? The same reasoning, use it for this one. There you'll have your answer. I grew up on you understood what he was saying, right? So the same reasoning applied here. That's how you get the answer for these outer terms that we multiply.
Oh man, it's not right.
No, but you didn't even say it.
Minus,
If it's incorrect, we'll correct it. I agree that's the whole point of our class.
minus 14.
minus 14a.
14a.
Minus 14a. You thought about it correctly, like 100% correct there. But here it just disappears. How does that happen? You see? So, and I say, trust your answer. If it's not correct, this is a safe space. If it's not correct here, you correct it. Yeah, that's the whole point of your private tutoring. Okay? So yes, you're correct there. You apply the same reasoning there, and you get negative 14a. Now, we're going to do our inner. Okay? And our inner, it's 4 times 3a. And what's the answer there? Kopa, would you like to give it a try?
12a.
It's 12a. How did you come to that conclusion?
Same thing.
Same thing. Okay. Kopan, do you agree with that conclusion? Okay, so it's 12a, I guess. And then the last ones, we've got 4 times negative 7. How much is that? Hmm? 4 times negative 7.
Minus 34.
That's incorrect.
No, that was close.
I mean, if it was 29, I'd say close, but 34 is too far, bruh. 34 is too far.
28x.
Where do you get the x?
Oh, negative 28.
Negative?
28.
Okay, negative 28. All right, cool. So the first ones are 2a times 3a, that gives us 6a squared. The second, the outer terms give us negative 14a. The inner terms give us plus 12a. The outer terms give us negative 28. Yeah? But now, we're not done because we've got terms that are alike here. And why do we say they are alike? Ne? It's because they have numbers that are coefficient to the number a, to the alphabet a. So that means we can simplify this with addition or subtraction. Because that's one, I get. If it was squared on one of them, we just leave it at that. Like, we can't add the 6a squared to any of these because it's got an unknown with a higher degree. These ones have an unknown with the same degree. This one has an unknown to 0 degree. So what do we do next? We just simply say 6a squared minus 2a minus 28. And that's our answer. So before you understand factorization, you have to understand how to multiply stuff out. And I think that's where your challenge is. You don't seem to have a good grasp on how we multiply out and distribute factors. Because once we understand how we distribute factors, we can understand how we separate them and factorize. So you gotta be able to, remember, when you are sitting and you're breathing, for every in-breath, you have to have an out-breath, right? For every time you sleep, you wake up the next day. For every time you eat, you empty out. For every time you drink water, you empty out. So in order to understand factorization, you need to be able to distribute and multiply out this way so that you can be able to think about it in reverse when you factorize. Ne? So Tabis, I'm going to encourage you, practice these and make sure you are good at them, because when you practice them, and the best way to be good at maths, and every mathematician whom you can think of, or a lot of them, have had to practice. You can only get better at something if you practice. So practice these examples. Make sure that you can, even if they have answers that are given there, try it by covering there, so that you understand how to do this stuff all on your own. Then when you get off the bicycle and you take off the training wheels, then you can ride it on your own without training wheels. But you have to practice. You don't expect Mr. P will put the answers in your head. I'm not going to figure out for you what's 4 times -7 in a test if you can't multiply that by yourself. You have to calculate that in the test by yourself. I get? Yeah, so I'm speaking about the tough talk because it has to be said, because practice makes perfect. That's the best way. So you can come to me, you can watch my videos all you want when I've uploaded them. It's fine. But if you don't practice, you will not get it right. And you only practice by giving yourself time to study. So even after our class, I will encourage you, please take an hour, just go through the stuff. You'll finish school, you'll get to college, technical, university, the lecturer will tell you the same thing. Practice. After class, sit down and revise. You get to work, you've completed a task, you make notes. What have we accomplished today? This thing never ends. It's the same. Always, it's the same. After a class, you sit down, you do it by yourself. Okay? So, Chabiso, in order for you to understand factorization, by all means, go through this algebraic expressions chapter and see how far you can go on your own. Just multiplying out, playing with the factors, multiplying factors by factors. Check yourself against answers first. That's your training wheels. After training wheels, you can take on the challenges without training wheels. But I promise you, if you dedicate an hour just learning these and looking at the answer and how they got it, and you challenging your answers, after 2 tries, you'll be confident to try these on your own. I promise you that. But you have to apply yourself. You're not going to get the answers downloaded into your head from Mr. P. Mr. P will explain them to you in a way that you didn't see, sure. But at the end of the day, he's not going to write your grade 9 final. You are. Okay? Yeah, so a little bit of coaching there. I think our class can be dismissed now. I want to find out, are there any questions? No questions. Okay.